or identify those changes that needs to happen in order for it to fit into our industry, in this case the broadcast industry. So both of those things actually happen, and I think it was really quite a pleasure because I've been part of it. I was a contributor to TR03. It was really good to see that both embracing existing standards and at the same time adding to it or correcting it or removing certain pieces of it when it didn't make sense. And then SMPTE 2059-2, which is the timing specification, and then the SMPTE 2022-7, which provides redundancy, which is about, okay, I have a network A and I have a network B, and my camera is going to send to both these. Maybe there's more, but at least in the minimum 2. And then my video switch is actually going to receive both these copies, so that if I happen to lose a packet or there is some latency or something from one side, it can actually put it together. That is what 2022-7 is all about. It's actually, when I came across 2022-7, it was kind of exciting to note that we have a very similar specification way back from 2006 or 7, I don't remember when, that also does the same function, but it is used in the WAN environment where at the WAN edge you actually take a copy, you distribute it across 2 ISPs, and then you put it together on the other end so that you don't have if you lose one connection, then you can revive yourself with the other. But it's subtly different about how they put it together, but on the other hand, the ultimate idea is the same. And then the AMWA and registration, ISO file, which actually provides the connection or the information to both the senders and receivers so that they can actually connect and draw flow. And then finally the ISO 6, which is the network control API. That's the one we will go a little deeper into in the next few slides. I speak a little fast. It just I guess I get excited, or I think it's just my nature to speak fast. So if I go too fast, just put up your hand or something. Just tell me in some way, and I will slow down. It's I always make up my mind to be slow, and then as the minutes go by, I'm just speeding up. It just happens to be one of those things I can't get rid of. In terms of AMWA NMOS, they are not a standards organization, just as SMPTE is. On the other hand, they are an organization which is pretty much community driven, and their whole objective is really, let's get the people together, let's work on some common problem that's been identified not by them, but eventually can be tracked back to the JTNM, which is a joint task force that John mentioned. So take a problem or a use case or a business need, and I think they were very, very particular on that it's not just a bunch of engineers saying, oh, we need to develop the next specification, but it is really a business need that drives a work group to be started, and then some number of people get together and decide or talk about how that particular problem has to be solved, or what are the pieces of that specification, and then it all comes together. And one of the key things about the AMWA specification is that there are a number of interrupts, and these are engineering type, not the public ones, but the engineering type, so that all the different vendors can bring their pieces to it, and they actually put it together and then see if it works. And invariably, every one of those in the exercise in the beginning always do understand that this does not have the same stamp of authority as that of another standards organization. On the other hand, it does solve the problem. Now, whether it will eventually get adopted by some standards organization, I do not know, but because I am not one of those leaders there, but that is the key thing that this organization is motivated to do. And I've done I have published standards in IETF and IEEE and other places. I can tell you things can take way lot of time. I mean, I had like a 4-page draft once in IETF, and it took some number of years, and I don't even think there were that many words in that. I mean, in some ways it just felt wrong, and I think that was my last draft that I did for IETF. But in any case, it can take long because there's a lot of process, and due process has to be followed. This one is a little bit different. But in any case, they also are more, I would say, friendly to adopting JSON and HTTP, these kind of APIs, but I think that is not technology. So that's kind of how I would say. These are, I mean, it's not because they are NMOS that they're doing this. It's because if I'm doing an API, then I'm going to look at REST-based APIs and so on. So The first functions of that is to discover what the network is all about. Okay, what's the network? Is it how many switches there are and how are they connected and all of that stuff that forms the network topology discovery. The next thing that will happen is, okay, once you've discovered the network and you've also already before discovered the senders and receivers because of ISO4, and you have also done some connection management exchanges using ISO5, then you are kind of ready for a flow, and the network controller makes it happen. So that's the second part of the ISO6. And the third part of ISO6 is all about, okay, you know, monitoring and diagnostics. Yes, we need to know at any given time, maybe, you know, with this flow, who's sending this flow and how many people are receiving these flows, what is the link utilization, or, you know, how much capacity in that whole network have I utilized, and do I have capacity to do X, whatever the next future thing is. And then also about failure handling, because in the IP network, links can fail, switches can fail, and so on. So when that happens, how does failure handling happen? How does it get notified so that somebody actually knows exactly where the failure is, and how is that immediately taken care of? So all of these things are the functions that are being done because of network ISO 6 and the exchange between the broadcast controller and the network controller. So you know, while I talked about you know, when I mentioned those three things, I actually didn't quite mention this function. So I'm going to go down and talk a little bit about one or two things that it does, which is of high value. So one of the things that it does is what is called an endpoint authorization. So like I said earlier, we can have any number of any source kind of connecting to the IP network and a receiver being connected to the IP network. And from the network perspective, from a switch, IP